How are
I'm
you?
good, thank you. How are you?
Good,
Yeah,
good.
good. How are you?
Very good.
Good.
Now, with that done, I'll take up another type of example, which is involving vectors. So I saw in many of your examples, when you're talking about position, displacement, velocity, and acceleration,
Mhm.
vectors come very handy, and it's a very important thing to learn. Many questions can be solved using vectors, right? So I'll give you some basics about vectors and then take up 4 or 5 questions. I have some figures here which are related to the questions which we are going to take in this particular example. So what are vectors? As you know, vectors are the things which have both direction and magnitude. The other quantities are scalars which do not have direction but they have magnitude. So position is a vector,
Yeah.
displacement, velocity, and acceleration are vectors. On the other hand, distance is scalar quantity. It does not have a direction. Similarly, speed, which is the magnitude of velocity, is also scalar quantity, not a vector quantity. Correct? Now, vectors can be represented in many different ways. And of course, the coordinate plane is probably easiest to display the vectors. So, what I will do here is on this particular graph, I do have a vector. Now, this vector is starting from a point which is at the origin. So, we call this as a position vector. So position vectors are those which will start from origin. So in general, if I say there is a vector this, you can always draw a coordinate plane and start this vector from the origin itself. It makes things very simple. Now, this vector, which is starting at the position O, which is the origin in this case, is going to point A. So we'll call this as a vector OA. So we'll write an arrow showing that it goes from O to A. Now describing it on the coordinate plane becomes simpler if I take I as a unit vector in X direction and J as a unit vector in the y direction. Then I can split this vector in two parts, I component and the j component. Everything which is towards the right hand side and going up is positive. So in this particular case, you can see that moving from O to A will be moving 1, 2, 3, 4 units right. So I could write this as 4i, and then we are moving down 1, 2, 3 units. That means minus 3j. So that represents the vector OA. Is that clear to you?
Yeah.
We also write I and j when we write with cap on top. This signifies a unit vector, right? So this I and j are unit vectors in the direction of x and y. Now, to find the magnitude of this vector, we'll write OA, magnitude with absolute bars. It's like a, you know, we can use the Pythagorean theorem, right? So that is the hypotenuse of a right triangle, correct? So you can see this is a right triangle. So we know this is the hypotenuse, and therefore we can write this as square root of a square plus b square, which is 4 square plus 3 square. Minus 3 will become plus 3, so I've written like this, which is 5. So the magnitude is 5 for this particular vector. To find the direction, we know that it is moving downwards from x-axis. So the angle theta is negative. You could write this angle as negative. The other convention is to always write angles as positive when they are seen counterclockwise. So that is the angle which could be the answer. Now, to find the answer, what we do here is we just do tan of theta, which is equal to opposite side over adjacent, the ratio. In this case, the opposite side is 3 units, and that is 4 units, so that is 3 over 4, and the angle theta will be tan inverse of 3 over 4. You can calculate this. Now, this angle is not the true answer. What we have done here is we have taken the positive values. Now, Once you have sketched, you can write this answer depending on the situation. You can write this answer as the angle is equals to minus whatever you get, since this is a negative angle, or you could write this as 360. Let us say phi is our angle. So we'll say phi is equals to minus theta, or we say phi is equals to 360 degrees minus theta, right? So in degrees. So that is the other angle. So that is how you could give the direction to the vector. So what I've explained to you is what is the position vector, how can we find its magnitude and its direction. So all the
Mhm.
vectors should be treated in this particular fashion. Is that part clear to you?
Yeah.
Perfect. So we have also discussed how to find magnitude and direction. We also covered what is a unit vector. Unit vector has a magnitude of 1 and the direction will be either in the x direction, then it is a unit vector I, or in the y direction, unit vector j. Displacement. Change in position is displacement. As you can see, O to A will be the displacement. We'll look into velocity, acceleration, and distance with the help of some examples. I've given you some diagrams which will help you later. Okay, so let's take the
Just a
type.
quick thing.
Yeah, sure.
Sorry, but in one of my questions in my book, I found the angle like you did here, and then I did 360 minus that. But
Yeah.
their answer was 180 minus that. So I don't understand why they did 180 instead of 360.
Okay,
So
so
could you show me
send
like
that
the
question to me.
conditions?
I do have a question similar to what you're talking about. We will see
Oh, right.
why it could be 180 minus that. It all depends when we are
Yeah.
trying to give the angle. It could be with reference to x-axis. It could be with reference to the y-axis. So if it is reference to
Oh,
y-axis, in that case, the answer could be 180 minus or plus, depending on what the situation is. You get my idea?
all right.
So
Yeah,
let's go
yeah,
through some examples, and I hope that point will be covered in this video. Okay. Now, can you please read these four questions?
yep. Um, okay, so question one. Vector AB has a tail at -1, -3, and a head at 2, 1. Sketch the vector AB, find the magnitude of the vector AB, and then determine the coordinates of the point D on the vector CD if C is 2, -2, and AB, like the vector AB equals CD.
Correct. How will you approach this question?
Um, so I'll first like get a sketch a coordinate grid, or if they give
Correct.
one, and then start plotting the points. So if it says I'll just put the tail and put the head and then join the line like that,
Correct.
find that will be AB, and then put the direction from A to B because it says
Perfect.
sketch the vector. So the arrow is important
Yes.
since it's a vector quantity. Then find the magnitude. So is that where you said just Pythagoras' theorem, where
Correct.
you go along and then square that, and then, yeah,
Yes.
square root that. Then determine the coordinates of the point D on the vector CD
Yes.
if C is this. So I'll plot point C,
Let's say
and
this is
then if
AB,
I
and
know,
yeah, we know this C. We have to find D. This is AB. How will you find D?
okay, so since we know the that A, oh, that's AD.
Sorry, AB.
Or did you mean B? Okay, cool. So if it was AB, then that magnitude, whatever that value is, CD will also equal that, and then you need to find the coordinate point in which, when you do Pythagoras' theorem, can you work backwards? You can literally just go c squared equals a squared plus, or no?
Yeah, you could do backwards. Okay. Now,
That
well,
could be long. I don't know.
that could be very long. So what you're trying to say is we
Yeah.
need to equate AB magnitude with CD magnitude, correct?
Yeah.
Now, if you follow this method, this is where I was. If you do this, then it will be a very long way. So I will say, don't do it. Okay, this will not be
Okay.
correct, and this will lead to difficulty. So let us see our approach of solving this particular question. Of course, the first half is exactly what you said. So in this, we have a vector AB whose tail is at -1, -3. So we are given that vector point A, which is at -1, -3, and B is shown at 2, 1, So vector AB is given in this solid line. Now, to find the magnitude of this vector, we'll use the distance formula using Pythagorean theorem. The distance formula, as you know, is x2 minus x1 whole square plus y2 minus y1 whole square, right? So that is the distance formula which we have used here, and the distance comes out to be 5 units. To find the angle, which is the next part of it, in this case, we're saying find the direction of vector AB from the unit vector I. So this is very important. We have to find the direction from the unit vector I. It really means unit vector I will be in the direction of x-axis. So you have to find the angle theta as shown here. Now clearly, we can actually think about this as a right angle triangle. We can use the tangent ratio, change in y over change in x, and that gives you 4 over 3, and the angle will be tan inverse of 4 over 3, which is 53.1 in this particular case. So we get our angle
Yeah.
theta, and that is with reference to the unit vector I. So this part is done, very clear, no doubt about it. Perfect. The second part of this question is kind of tricky. Now, in the second part, well, I'll show you here because I think I did not copy that. Anyway, here, there we go. So we did this part, which is we found that the angle was 53.1 degrees, and now we need to find the point D. So we are given that we need to do this part. Determine the coordinates of point D on the vector CD if C is 2 minus 2 and AB is equals to CD. So clearly AB is drawn as we did last time, and C is the point given to us. So what you could do here is, since we know that these two vectors are same, their magnitudes will also be same, you can calculate the length and then equate the lengths. However, I will not go further from here because that leads to a lot of difficulties. You have two variables, x and y. Point D will have two variables, x coordinate and y coordinate. But this distance
Hmm.
formula will give you one equation, and you need to find two things, so it will not really work. So what's
Oh,
very
right.
important here is to look into the gradient part also. Do you understand? So the gradient part is kind of clear. So we know that the gradient is also same because they have the same direction, right? Same
Right.
direction means same gradient. The gradient of the given vector AB is 4 over 3, right? So that is the gradient of the given vector. So the vector CD should also have 4 over 3 as your gradient. And we are using the point D as xy. And therefore, y minus y2 over x minus x2 will give us the gradient. Equate it to 4 over 3. Now, how do we get two equations from here? Can you see? The two equations are equate the numerator and the denominator. So equate the numerator and denominator. So this is denominator. That is to say,
Oh,
3 should be equals to x minus 2. And that is the numerator.
that makes sense.
So we did slope, no
Oh,
calculations required of distance, nothing to do with quadratic, and simple linear equation. Just equate and you find the value of x will be 5 and the value of y will be 2 to satisfy this particular equation. You get the idea. So
so what you're saying is if two vectors or like multiple vectors, if they have the same magnitude, it means they have the same direction, so
no,
same
no, no.
gradient.
If two
Oh,
vectors are equal, then they have the same magnitude and same direction. If they have the same magnitude, they may not be equal because the direction may be different.
oh, but since here it says we're
Equal
saying the
vector,
direction is both going in the same. Oh,
because the
right.
vectors are
Okay.
equal, not even the vectors are equal, both the things, right? Now, I'll show you another neat way of doing it on the graph itself. This vector we found was 4 over 3, right? So that, or you can say
Yeah.
3 4. Move 3 units towards x, 1, 2, and 3, and 4 up, 1, 2, 3, 4. You get a point. Read the point. And this point clearly is
Oh,
from here 5
5 2.
done. No calculations required. So if you are given a graph paper or you just plot small sketch as it is, you know clearly that the vector which you're looking forward will be CD, where point D will be 5, 2. Do you see that?
Mm.
That's the beauty of vectors. And most of the questions in vectors will be done like
Oh,
this. No calculations required.
all right. Okay. Yeah, that
Perfect.
was good.
Yes,
Yeah, that was good because yeah, when if you were gonna do like the one that you put an X next to, which my mind was gonna go to, I would have been there forever, and then it ended up with only one solution. So
yes,
that would have been pointless.
correct. Now let's look into the second question. We'll do four in this particular case. Can you please read the question number two?
The velocity of a car is given by v equals 12I minus 9j meters per second. Find the speed of the car, then find the angle the direction of the car makes with the unit vector I.
Perfect. Now, to find the speed, basically you have to find the magnitude. That is what speed is. Velocity is given to us as 12I minus 9j. So the magnitude of this velocity is a square plus b square square root. You get the answer as 15. So the speed is 15 meters per second in this particular case. To find the angle, so that is the tricky part. To find the angle, it is better to sketch first. So at this stage, when you are given this vector to us, then you sketch. When you sketch, you land up in quadrant 4, correct? So you clearly have an idea what is this angle theta. So you have to give this angle theta as a negative value. That could be the right answer, or 360 minus this angle. So basically, it is important to find the reference angle and then write down the answer. Correct? That is kind of very important for us to do. So here, what we have done is directly we just substituted the values and we got tan theta as minus 3 over 4. And when we use the calculator, we do get the right answer. The right answer is minus 36.9, correct? And
Mhm.
or you could write this as 360 minus 36.9 and you could write the right answer. So you do get
What?
in this particular situation the right answer. Yes.
Yeah, but what doesn't make sense is it says find the angle that the direction of the car makes with the unit vector I. So if it says unit vector I, it's just basically saying x-axis.
Yes. Unit
Or
vector
no?
I is x
Oh, so
because
you
the
have to write the answer as 360 minus that.
correct.
Or
Or negative of
oh,
that. So both will work.
okay. So the
Negative,
minus 36.9.
correct.
Right.
Both will work. Now, the caution here is I've purposely taken this example. Many students will think this gives you the right answer. Well, of course, next time I'll do next question where the answer will be wrong. So then you'll realize that doing this, directly substituting the values, is not a good idea. Okay, anyway.
Oh,
But we'll
okay.
discuss the alternate method. The alternate method, which is for me the general method to solve such question, is find the related acute angle. So a related acute angle means think about all the things in quadrant 1. So everything is positive. So we have tan beta as 3 over 4. Let this angle be beta. And we do not go to quadrant 4. We are working in quadrant 1. Find the related acute angle. Now, beta is 36.9 with the calculations. Since we know from the sketch that the answer lies in quadrant 4, therefore the angle will be right on the actual answer. Do you get the idea?
Oh,
360
okay.
minus this, like we do in trigonometry. So same concept has
Right.
to be applied to find the angle. And then you get your answer. Is that clear?
Oh, okay, yeah. So you're always doing like quadrant one or
Yeah. And then get the real
no,
answer.
always doing yeah. Okay.
So always find related acute angle. Perfect. Let's take question number 3. Can you please read this question?
Yeah. Um, the acceleration of a car is given by a equals minus 3I minus 2j meters per second squared. Find the magnitude of acceleration, then find the angle the direction of the car makes with the unit vector j.
Correct. So only thing is velocity has been changed by acceleration is the same vector. So the magnitude, no problems, a square plus b square
Right.
square root, and you substitute the values, you'll get 3.61 as your answer. Now, let's look into the angle part. So, like last time, if I substitute minus 3 over, minus 3 over minus 2, then what do I get? In that case, uh, I should have written the other way.
Change in y over change in
Yeah,
x.
because the y value is 2, right? So this is incorrect. Okay.
Right,
This,
I see it.
yeah, this is incorrect. Okay. Anyway, you may have, can you please redo the calculations? Let's do 2 over 3. So what is the angle you get?
Um,
Tan inverse
I
of 2.
don't have my
Oh, I have it here. Okay.
sorry, I don't have my calculator. I
If
mean,
tan inverse 2
in my
divided by,
bag.
no problem, I'll do it. 33.69. So we get 33 point, let's say 7, okay? So we get
Okay.
33.7 as our angle. Now see, when you sketch the diagram, the question is minus 3i minus 2j. You are in quadrant 3, correct? 33.6
Yeah.
is not a correct answer for sure. But 33.7, tan value is positive. That really means it could be in quadrant 1 or in quadrant 3 because tan value is positive, correct?
Mm-hmm.
In quadrant 3 also, it is positive. That's the whole key, right? Therefore, we will not go for straight answer. We'll go for acute angle. We clearly know that our angle beta now is 33.7, correct? So this angle beta is 33.7 degrees. Now, what do we need to find? The question says, find the angle the direction of the car makes with unit vector j. Do you see that? We have to find from here, j. So clearly from here,
Right.
this is vertically opposite angle. So this angle here is 33.7, correct? From J, it is
Yeah.
how much? 90 plus 33.7.
90. So you
So
just
we get
add
our
90.
answer as 90 plus 33.7 as our answer. So we'll just add 90 to this. You get the idea. So it is
Yeah.
103.7.
Wait, what topic is this again with the quadrant 3 and knowing the related acute angles?
In trigonometry, when you find any angle,
Okay.
that
Wait, in
those
okay. I
are the
think I need to revisit that.
yeah, you review
Yeah.
trigonometry.
Trigonometry,
Yeah, any angle.
any angle.
Correct. So you see, realize that it is better to find the related acute angle and then looking into the requirement. In this case, we have to find the angle from y-axis. It should be 90 plus the related acute angle, and that gives you
Mm-hmm.
the answer. Is that clear to you?
Yeah.
Perfect. That is how we'll do. Now, coming back to your question, if the situation is such that we have a some vector which is in this place, correct? In that case, that is the related acute angle beta. And if you have to find the angle from y-axis, then it will be how much?
360 minus beta.
270 minus beta. Because this is 99.
Oh yeah.
Get the idea? Then be 270 minus beta. You have to be careful. Depending on
Oh.
where you are, get the idea?
Mm-hmm.
And which
Right.
angle you have to
Yeah.
find. It could be a different thing. It is not always 360 minus theta. Is that clear to you?
Oh, okay. Yeah.
So here's the last.
Yeah. Okay.
Can you please read this question?
An object moves from A to B and then from B to C. The displacement from A to B is 8I plus 5J kilometers.
Yes.
The displacement from B to C is minus 6I plus 6J kilometers.
Mhm.
Find the magnitude of displacement from A to C.
Correct.
Then find the total distance traveled from A to C, and then find the angle A to C, which makes with the unit vector I,
Correct.
so the x-axis.
So we'll go step by step. First
Okay.
is sketch your diagram, right? So an object moves from A to B and then from B to C. The displacement from A to B is given to you as 8i plus 5j. So on a coordinate plane,
Mm-hmm.
8i plus 5j, what I've done here is I've taken each as 2 units. So this is 2 units each. So 8, we'll go 4 units, 1, 2, 3, 4, and then we get point B. So that is my vector AB, right? So 8i plus 5j. And then from there, the second vector is minus 6i plus 6j. So that is the second position from here, and we land up at C. So we have our diagram. We really want to find total distance traveled from A to C. Remember, distance traveled. So distance basically means we'll add this distance AB to the distance BC. So we'll add both the distances to find the total distance. Individually, we can find both the distance. AB is 8 square plus 5 square square root, which gives us 9.433, and BC is 6 square plus 6 square square root, which gives us 8.485. Correct? Those are the distances. Add them up to get the total distance, and so you get the first part. Clear?
So you can't find the magnitude of AC and then do this whole square root like this.
That will be the
Okay.
displacement. Yeah. You have to individually add the distances, then you get the
Oh,
total distance, right? First you travel, let's say 2 kilometers, then you travel 3 kilometers. You will add 2 and 3 to get 5 kilometers as your answer, rather than direct as the crow flies. No, they're not that distance. That is the displacement.
oh, okay.
Now, second part is find the angle AC, which it makes with vector I, unit vector I. So that is the angle which we need to figure out. So that means we need to find what is the vector AC, right? Or displacement from A to C, the net displacement. So that is addition, right? So in a triangle, we use addition rule, right? So you can add. We know that AC is equals to sum of AB and BC, right? So add these two vectors to get the vector AC, which is the final displacement. So we added these two vectors. AC is AB plus BC. Adding them, 8i plus 5j equals to minus 6i plus 6j. Basically, combine the like terms. So in the I direction, 8 minus 6 gives you 2, and j direction, 5 plus 6 gives you 11. So you get the vector AC as 2i plus 11j. Once you have this vector AC, find the angle. Now you know the vector, this angle could be found by treating this as your right angle triangle. So tan theta will be 11, the y component, over 2, the x component, right? And theta will be tan inverse of 11 over 2, which is 79.7 degrees. So that becomes the angle with the x-axis. Is that clear to you now?
Yeah,
So
yeah.
that is how this type of a question can be done. So with
All
that, we
right.
come to an end of this
Yeah.
particular lesson where we cover how do we
Mhm.
solve questions based on acceleration, constant acceleration, and how do we utilize the learnings of vectors in solving mechanics problems. So these were simple basic problems, but later we will see how we are going to use vectors to solve really complicated questions involving mechanics, okay, even dynamics.
All right.
Perfect.
Okay. Yeah.
Yeah. So, Amy, can you summarize what you have learned in this second session on vectors as an application for position, displacement, velocity, and acceleration?
Yeah. So I kind of got like introduced today to the concept of this whole like IJ thing, which is in the position of I, you're going along the x-axis, and then J going along the y-axis,
Correct.
and then just whether it's positive or negative, that depends on the direction and the vector like that's given. So a couple of questions that we worked through. So like mainly when doing this, when you find your angle, like your angle theta, you use tan and then find the angle, but then you have to look what the question is saying and saying like where it's from. So if it's from I, then you would have to look from the x-axis and then find it. The angle can be negative if it's still from the x-axis, or you can do 360 minus that, or 270, or depending on what is given. So if it was 270, that would have to be from J, because you would like count like that. But yeah, anyways, so read the question when it comes to the direction of like the angle. And then when we looked, I think it was just the last question, which was quite important, like that I thought, was when you have like the magnitude,
Diagram is
like the vector that's given.
diagram of the last question is here. So all the three diagrams
All
are.
right.
Yeah.
All right. Okay.
Mhm.
Yeah. So with the last one, when we said from we've got the vector A to B and then B to C, we wanted to find the total distance, and I thought you can just take the like the ij of that, the A to B and then the B to C, and then just add it and then get A to C and then find it. But you can't do that, because A to C, when you do it that way, since it's the magnitude would be the displacement, but they're asking for the total distance traveled, so you have to find them individually, A and B and then B and C, and then add it like that.
Correct.
These things can look really simple, but it's just that when you're in the exam and stuff, like due to the pressure, your brain can do like really stupid things. So these concepts, like the basics, is really important to get nailed.
What you
You know?
also learn, Emmy, from here is that distance will always be greater than or equal to displacement, since sum of two sides
Right,
of the triangle is greater than the third side. You get the idea.
right.
So that actually
Yes,
proves that this distance will be greater than displacement. So with that, we
greater than
come to an
displacement.
end
Right.
our lesson on this mechanics, and I hope you got the concepts. You can mail me the questions which you have, and we'll discuss them later. Okay.
All right, cool. Thank you so much, sir.
All the
Thank you for this
best.
overview. Because when, like, even at school, I think, like I said, my teacher's been like absent and stuff. That's why I'm not really strong on this topic.
No,
I know it seems simple, but like my brain's not like kind of working around it. So yeah, my test is Tuesday, so I still got a loads of time to like really up my game. So yeah,
let
I'll
me know which are the
do a
days,
lot of practice.
and we will do rest of the
Yeah.
things on that particular day. Okay. Email me that. Perfect.
All right.
Okay
Perfect.
then.
Thank you so much, sir.
Great.
Have
Bye.
a
All.
good rest of your week.
You, you too.
Bye. Thank you, sir.